Good afternoon, geometry students. Thanks for tuning in to another video lesson. Flipgrid question of the day is up there. Go do it. It's fun. You've already found the YouTube lesson if you're here. And now, pause the video, pause it, and try this problem in your notes. And then unpause it to do it with me, to check your answers with me. Okay, we are asked to find the area and circumference of a circle with a radius of 4.5 meters. Okay, I want to get a visual of what this looks like. So a circle with radius 4.5 meters, something like that. Okay, so remember area first. Area is pi r squared, and I remember that because pi r not squared, pi r round. Okay, so this is pi times the radius, which we are told is 4.5 meters squared. So now all I do is I take my handy dandy calculator and I take pi times 4.5 squared, and I get approximately 63.6 units meters. Just like that. Done. Put my units on there. No, you did not. Meters squared. Because we're talking about area, and remember area is 2 dimensions, 2-dimensional, that's where the squared comes from. But also, look at this, u squared, 4.5 meters squared. So the meters should also be squared, as well as the 4.5. Okay, beautiful. Area, check. Now circumference is equal to pi times the diameter, or pi times 2 of the radius, which is pi times 2 times 4.5, which is approximately, wow, we are really squishing it in there, pi times 2 times 4.5 is approximately 28.3 meters. Done? Yes, because circumference is just the distance around the outside of the circle. It's not 2 dimensions. When we talk about area, we're talking about everything inside of the circle. But when we talk about circumference, we're just talking about this 1-dimensional. Like if we took that circle and stretched it out, we would just get a line, a 1-dimensional line. So yes, that one's just meters. This one is meters squared. Don't forget your approximate symbols because these are crazy long decimals. Okay, cool. Found the area, found the circumference. Awesome. Moving on to what we have for today. Now last time we did 11.2 or 11.1 and 2 like smacked together, and the required portion of the video was only 25 minutes, but it looked really scary because it was like a 40-minute long video. We're not doing any bonus stuff today, so it's going to be a nice short and sweet video, so don't be nervous about anything bonus. Okay. Learning target. I remember what rhombuses, kites, and regular polygons are. Yeah, we're going to review chapter 7 again. And you can find the area of rhombuses, kites, and regular polygons. So we're going to review a little bit of chapter 7, and then we're going to learn something new that we didn't learn in chapter 7. Okay. So first thing, you should pause this video and write down everything inside of this box. Picture this formula. Important. Pause it, write it down, unpause it. I'm going to tell you a little bit about it. So what they mean by D1 and D2 here are they are talking about the diagonals. Remember, a diagonal connects opposite corners. And not necessarily the exact opposite corner. Remember that if we have a pentagon here, this is a diagonal and that's a diagonal. It's just non-adjacent corners, non-adjacent vertices. So they're looking at the diagonals. This is one diagonal, and this is another diagonal. Same thing here. This is a diagonal, and this is a diagonal. And the area of a rhombus or a kite with these diagonals is 1/2 times diagonal 1 times diagonal 2. The end. That's it. If you want to know why, there is some very interesting information in our textbook that explains Why? Because diagonal 1 times diagonal 2, and the different you could see there's 4 triangles right here, and the formula for the area of a triangle is 1/2 base times height. So if this is our base, we take half of diameter 1 for the base here, half of diameter 2 for the base there. So all of these triangles have half diameter 1, half diameter 2. It's very interesting. It's very interesting. I'm not going to go over it here for the sake of time, but if you want to talk more about it, join my office hours or look at our textbook online. It is very fascinating. This is the takeaway. Rhombus or kite. There you go. Area of a rhombus or kite. Boom, right there. Let's do some examples. Find the area of a rhombus or kite. Hey, okay. We just learned that the area of a rhombus or kite is 1/2 times diagonal 1 times diagonal 2. So here, we're going to have the area as 1/2 times... Does it matter which one is diagonal 1 and which one is diagonal 2? What do you think? If I made this one diagonal 1 and this one diagonal 2, I have 8 times 6. And if I change it, and I make this diagonal 2 and this diagonal 1, now I have 1/2 times 6 times 8. That's the same thing. So it does not matter. Nobody cares which one you use as diagonal 1 and diagonal 2. 1/2 times 6 times 8, that's 1/2 times 48, which is 24 units. Meters. No, not just meters. Meters squared. Meters squared. Because remember, this is 6 meters times 8 meters, and meters times meters is meters squared. Also, area is 2-dimensional. Yeah, you get it. It's what we talked about in the entry task. You get it. And that does say dimensional, believe it or not. Okay. Moving on. That was the rhombus. Now let's move on to the kite. Area is 1/2 diagonal 1 times diagonal 2. Again, doesn't matter which one is diagonal 1 and which one is diagonal 2. 1/2 times 7 times 10. That's 1/2 times 70, which is 35 units. Centimeters. And we don't have any crazy decimals here, so I can use the equals sign. I don't have to use an approximate. Boom. Boom. Okay. I hope you enjoyed that. Nice and easy. Should not have any problems with these. If you do, for some reason, that's okay. Just make sure you talk to me about it. Okay, and look at that. 24 square meters, 35 square centimeters. We were right. Woohoo! Okay. Next, we only have one more example, folks. And in order to do those examples, you need to know what an apotheme is. Apotheme, apotheme, I don't care how you pronounce it, as long as we're on the same page. So, please write this down, pause the video, put that red box in your notebook. The distance from the center to the side of a regular polygon. So this right here. If we were to look at this, that is not the apotheme. This is not the apotheme. We are taking the shortest distance to the side. The shortest distance is wherever this is a 90-degree angle. So not this. Not this one. Yes, this one. So not what I just erased. This is what the apotheme is. From the center to the middle of the side at a 90-degree angle. Okay, that's what an apotheme is. It is important for finding the area of regular polygons, which, remember our entry task, we're going to find the area. Or not our entry task, remember our success criteria. You should be able to find the area of a regular polygon, and the apotheme is going to help us do that. So, next, make sure that this is written down, and let's move on. Okay, this is also important. Write down what is in this red box. It's another formula. The area of a regular polygon. Remember, what was a regular polygon? That means that all these sides are the same length, and all these angles are the same angle. So if you have if you have something that looks like this, that is not a regular hexagon. Because look at that, this is so much smaller than this. So, not regular and regular. So, when we are talking about the area of a regular polygon, the area of a regular n-gon with side length s, so that's what this s is right here, and that's what, I'm gonna erase those markings. S is the side length here, is 1/2 the product of the apothem A and the perimeter E. That sounds very complicated. All it is saying is that if you take the apothem, this guy right here, and then you find the perimeter all the way around this guy, multiply the perimeter by the apothem, 1/2, done. 1/2 apothem perimeter, done. You can also use 1/2 of apothem times the number of sides times the side length. This is just the perimeter in disguise. So, yes. Yeah. Number of sides times the side length, that's just the perimeter. So these are the same formula, just written a little bit differently, because the perimeter is equal to the number of sides times the side length. Okay. Make sure that especially these two boxes are in your notes, but this picture, everything in this box should be in your note. Okay. Let's move on and do an example. No, before we do that, where does this formula come from? Where does this formula come from? How did we make it? How did we create it? Well, see how they split this up into triangles? See here we have 1, 2, 3, 4, 5, 6 triangles. Just like when we triangulated shapes in chapter 7. All of these triangles have the same area. So if I can find the area of one of those triangles, I just have to multiply it by 6 and now I have the area. That's how they got this. Was the area of a triangle is 1/2 base times height, and the base is s, so we have 1/2 s, and the height is a, the apothem, so we have 1/2 times s times a. But remember, we have the number of triangles that we have is n. Excuse me, it's not s, it's n. It's the number of triangles that we have. So that is where they got this first line here. They did 1/2 base times height, and then, so this is the area of a triangle, and then we need to take the number of triangles to get the entire shape. And then they're just reorganizing it. The perimeter is the number of sides, so they just replaced n times s with p here. And that's where you get it. And I think it's really cool, so I wanted to share it with you. Now, let's move on and do an example. Okay, so remember that we have area equals 1/2 of this guy right here. 1/2 of the apothem times the perimeter. And don't forget that the perimeter is the number of sides times the side length. Okay. Awesome. So, let's see. The apothem, right off the bat, I see that the apothem is 6.5, and the perimeter is number of sides, 1, 2, 3, 4, 5. Perimeter, whoops. Perimeter equals 5 times the side length. The side length. What's the side length? I don't see it. Oh my goodness, what the heck is the side length? Is there any way that we can figure out what the side length is? Hey! I have a right triangle right here. What do I know about right triangles? That's right. We know a squared. In fact, let's do a different color. We know a squared plus b squared equals c squared. So I can find this chunk of the triangle, and then I know two of those. If I just take this plus this, then I can get my side length. Okay, so remember that c is the hypotenuse, and then it doesn't matter what a and b are. So we have 6.5 squared plus b squared equals 8 squared minus 6.5 squared from both sides gives me b squared equals squared minus 6.5 squared 21.75. Take the square root of both sides, and b is approximately 4.7. Approximately 4.7. Now 4.7 was just this chunk right here, and we want the whole side. We want the entire thing. So we need to do, so this is b and this is b, so we need to take 2 times b in order to get our side length. So our answer times 2 is 9.3. And I know 4.7 times 2 is 9.4, but I'm just going off what the calculator said. 4.66 times 2 or whatever. Okay, so, beautiful. Let's go back to our formula right here. We have a 1/2 times that apothem, which was 6.5, times the perimeter, which is 5 times 9.3. And if we put that 1/2 times 6.5 times 5 times 9.3, I get 151.125. Still doing approximate because this was approximate. Remember, since this was approximate, that means this is approximate. Because this is approximate, this is still approximate. So if you have one thing that's approximate, everything becomes approximate. An approximation. And they didn't give us any units. So there you go. The end. You will not always need to find the side length like that. Sometimes they will just give you the side length. So this is the most complicated of the examples you're going to find. Some of them, S will just be given to you, and all you have to do is plug in A, S, and N. Sometimes all you'll need to do is plug in those 3 things. Okay, awesome. Yeah, I didn't like their example. Their example was a little bit different, so that's okay. If you have questions, please, please, please be sure to ask me. I want to help you. I want to answer any questions that you have. So, office hours are every Tuesday through Friday, 12:30 to 3 p.m. I'm also available many other times, so you can just email me and set up an appointment for another time if you're like, 12:30 to 3 doesn't work. That's okay. You can email me, and we can set up another time to Google Meet, set up another time to talk, or we can just answer it through email. Whatever you need. That's what I'm here for. Whatever you need. So please, please ask me questions. Your homework, 4 questions like the first example, 4 questions like the second one. You'll see, here they give you the side length. No need to solve for it. Here they give you the side length. Here they give you the side length. This is the only one you have to solve the side length for. So these are going to be a lot easier than the second example we did. Yeah, okay. Lastly, your lunch for today is from Napoleon Hill. Don't wait. The time will never be just right. Now, of course, this does not apply everywhere. This does not apply everywhere. Don't wait to do drugs. The time... No. That's not what this is saying. That's not what this is saying. Always wait to do drugs. Never do drugs. So obviously that's not what this is talking about. What this is talking about is don't wait to go to college. Don't say, I just want to take a gap year, save some money, figure out what I want to do with my life. Maybe. Usually doesn't work out too well. So don't wait. The time will never be just right. Yeah, don't wait to do something that you're really passionate about. I really want to learn the piano, but I want to wait until I have a bigger room or until something. You want to wait for XYZ. Like, no. If you're really passionate about something, don't wait. Time's never going to be just right. So don't wait for time to be perfect. If you're passionate about something, do it. Unless it's drugs. Don't do drugs. Yes. That's my lunch. That's my lunch for you today. Take it with you as you go throughout your day. And thanks for being here. Thanks for watching. Have a wonderful rest of your day. Bye.